There's a lot of noise right now. Is AI a bubble? Is it overhyped? Will the investments pay off? Will it replace jobs or create them? Honestly, nobody knows for certain. The debate is still raging. But amid all that confusion, one thing is already settled and established. Cloud. Cloud is not a trend. Cloud is not a bubble. Cloud is infrastructure. And here's the link. Every AI model you have heard of runs on cloud. There's no AI without cloud underneath it. It's the electricity of the digital age. You don't debate whether electricity is worth investing in. You just make sure you know how to ride the bill. Nowadays, every AI model is running on cloud. Every startup is scaling on cloud. Every government is migrating to cloud. Every enterprise that tried to avoid it is now on it. So cloud is not coming. Cloud is already here. And the architects who truly understand it, not just use it, but understand it, are the ones the industry cannot do without. And that's why we're here. Hi, I'm Ali Sajjad, a multi-cloud architect with around 18 years of experience in diverse technology domains: cloud, multi-cloud, databases, DevOps, data analytics, security, and governance, across government, banking, and enterprise projects. And this is the complete cloud architect. Let's begin. So now comes the natural question: which cloud provider should we learn? Who leads the market? Is it AWS? Is it OCI? Or is it the Azure or GCP? Honestly, there is no single answer. Oracle Cloud leads when it comes to database workloads, autonomous database, and enterprise applications like e-business suite and Oracle Fusion. Whereas Azure dominates in organizations deeply embedded in the Microsoft ecosystem, Active Directory, Office 365, Teams, SharePoint. And AWS, with its sheer breadth of services and the most mature ecosystem in the market, remains the default choice for the startups. Each has its place, each has its strength. But here's the reality: gaining deep hands-on expertise across all three simultaneously is not practical. Certifications go out of date, console steps change overnight, features that existed last quarter get deprecated and redesigned. So if we build this course around clicking through the menus, it would be outdated before you finish watching it. So we took a different approach entirely. The course is built on three pillars. The first, conceptual clarity. We go deep on every major cloud subject, not the buttons, but the principles behind them. Principles do not change when AWS updates its console. Second, a cross-cloud commonality framework. After every chapter, we sit all three clouds side by side, same architectural patterns, three different implementations. You will understand not just what each cloud does, but why it does it differently, and which one to choose for a given situation. And third, three layers of depth designed for three different audiences. Real-world analogies for those who are new to cloud and need a bridge from the familiar world they already know. Then the real-time scenarios for the working engineers who need to connect the concepts to what they see in their the current consoles, their pipelines, and their 2A incidents. The real architectural patterns for experienced architects who need the precise terminology, the trade-offs, and the design decisions they can defend in a boardroom. So wherever you are in your journey, this course is built for you. Tune in, stay with us, because by the end of this, you will not just know cloud, you will think in cloud. So let's start with the question that every cloud conversation eventually comes back to. What service model should we use? What is on-premises? On-premises is you own a data center and where you already have your entire hardware, your operating systems, your runtime, your app and data, everything running inside your data center. So that's the on-premises definition. Very straightforward and simple. It's a very traditional approach where every company used to either have their own data center, or they used to go on commonly available data centers. They used to lease the servers over there. When it comes to infrastructure as a service, and this is take and bake concept. The provider gives you the physical infrastructure, the compute and the storage, the network. the racks, the server racks, the storage area, the sandboxes, everything. And you just bring your own OS and the middleware and the applications over there, and then you do your stuff. You install the databases and applications and everything. So this is what is called the infrastructure as a service. When it comes to a PaaS service, it's something like someone delivers a hot pizza to your door, which means you don't need to really worry about the infrastructure as well. So it's something like the entire infrastructure and the underlying operating system, everything is being taken care of. The software, if it is a database, let's talk about an autonomous database. So the database, operating system, the storage, everything is being taken care of by the provider, and you only import the data inside this database, and then you start connecting the applications and start using it. So this is a PaaS model. Now comes the SaaS model. It's typically the commonly given example is a kind of a restaurant where you just walk in, you sit down, and you eat it, and then you just leave the restaurant. You don't own the restaurant here. There is publicly available consoles which provide you the access. You create your logins, and then you start dumping your information, and then it's all the SaaS product responsibility to manage the entire infrastructure, as well as the database, the data, how the data goes in, how the data is being, the performance of the data, everything is being taken care by the SaaS product here. So here you're just worried about just the data, how you're going to insert the data in here. So that's the SaaS model. And then comes the FaaS model, not very commonly known. This is kind of a vending machine where you don't even go to a restaurant here. You just press a button and something comes out of it. You pay exactly for what is coming out. So it's in other terms, it is called as a serverless model, where apparently there is not even a server running for your services. You're not even worried about the server. You don't log into the server. You don't get access to the server. All you need is a console where you just push some job, and then that job will be basically, when we say the server, we are talking about the compute resources like the CPU and the memory. So when it is a server, whether it's a PaaS or it's a IaaS model, here you are at least worried about how much memory you need and how much CPU you want for the server. Even for the PaaS models, you are worried about it. But when it comes to the FaaS model, you just push a job, and the provider decides how much memory and how much CPU is required, and then it will run the job at the back end and then just gives the result to you. The best example here is like AWS Lambda functions, and then Azure functions, OCI functions. So these are all the FaaS models. So moving forward, now if you look at the spectrum at the bottom of the slide, more control on the left, more abstraction on the right. So on the left hand side, you see you have more control on the servers. As you move towards the right, you are losing the control on the infrastructure and the management of it. You're losing that control, and then you're giving it entirely to the cloud. So that's how these service models work. So neither extreme is better. The right choices depends on your workload. So here's something very important, worth taking a notes, and this will be, useful throughout your career when you're dealing with the multi-cloud or the cloud models, different cloud models. It's called the shared responsibility model. It works for every layer, like for security, for the responsibility, for the business availability, all such the components. So the shared responsibility model answers one of the most misunderstood questions in the cloud. When something goes wrong, whose fault is it? So the cloud providers owns everything below the hypervisor. Irrespective of which model you choose, it's IaaS, PaaS, or SaaS. Anything below the hypervisor is being managed and owned by the cloud provider. Now, after that, the physical infrastructure, the data center, the servers, the virtualization layer. So all these stuff is the Oracle's problem, or the Amazon's problem, or you can say Microsoft problem. It's not your problem. But anything above the hypervisor, it depends on what you choose. For example, like if infrastructure as a service. Yeah, for example, if infrastructure as a service, you own the operating system and everything above it. You patch Oracle Linux, you configure the firewall, you manage the agents. If your operating system has an unpatched CVE, that is your vulnerability. It's not the cloud provider. You cannot blame the cloud provider why my operating system is not patched, because in IaaS, Everything below the operating system is cloud providers, and then your responsibility starts from the operating system layer, and then what you have, what type of operating system you have, and the patching layer from the operating system, and then on top of it, what type of applications you install, what type of database you install. All these belongs to your responsibility, the customer responsibility, not the cloud responsibility. Now that's the IaaS. Now, when it comes to a PaaS model takes care of, like we discussed, it's the OS belongs to the cloud provider. Now, if there is an unpatched operating system, it's not your responsibility. You can directly blame the cloud provider, and definitely the cloud providers takes care of these on time. So you own the application code and the data here. So but again, like if you have an SQL injection in your app, now that's yours. You cannot blame the cloud provider about the SQL injection because you have not encrypted the data. You have to ensure the data is encrypted properly, and who is accessing the data, how is the data being accessed. It's all the customer's responsibility. So here's the responsibility model about the PaaS. And then when it comes to SaaS model, now here it goes further one more layer where the cloud provider takes furthermore responsibility regarding the SaaS model. That includes your data management as well. For example, you're least bothered about what type of database is being used in SaaS model. It could be Oracle, it could be PostgreSQL, it could be anything. And how is it being secured? How is it being partitioned or indexed? All such stuff is being taken care by SaaS. So that's not your responsibility how you encrypt the data on the SaaS models. But again, now it's your responsibility to ensure who has access to it. When you have data inside the SaaS model, if you are not sure who is going to access what type of data, then again that leaves to the customer's responsibility again. Now let's spend a moment on infrastructure as a service. This model, because this is where most enterprises cloud journeys begin, and where most architectural decisions are made. Now, for the beginners, think of IaaS like leasing an empty office space. The building is there, the electricity is there, the internet connection is there, but you bring your own desk, your own computers, your own team. You can design the layout however you want. Open plan, private offices, server room in the corner. Now, but if your printer breaks, that's on you. So you cannot blame the office owner, the owner of the building, that your printer has broken, because that's your responsibility. That's how the IaaS work. So for mid-level engineers, like let me make this concrete. In OCI, you spin up a compute instance. Let's say a VM standard E4 Flex. Now that's the shape of the virtual machine which you might have already chosen a lot of times. So there you will have an option of choosing the number of CPUs, OCPUs, and the amount of RAM, maybe 64 gigabits of RAM. You attach a storage, say like a 2 terabyte block volume. And then you install Oracle database. Now, why you install Oracle database? Because it's an IaaS, as I mentioned before. It only gives you the virtual machine, not the application on top of it. When you go for another different model, that's a DBaaS or PaaS model, where you are not even worried about the installation of Oracle database. That's a different model. We are talking about infrastructure as a service. Here we are only taking the virtual machine from the cloud provider. Now, what we install in it, it's our responsibility. We discussed this one. So now, once you start installing the stuff here, you can have 10 databases. You can have a number of applications running here. So you're not going to pay for the number of databases over here. You're only going to pay for the shape that you chose at the time of installing the virtual machine, the VM standard E4 Flex, 4 OCPUs, 64 gigabit of RAM, and then 2 terabytes of block volume. So this is the infrastructure that you took from the owner, and you're only going to pay for it. Now, what is inside these servers, it's not the cloud's neither responsibility, nor they are going to bill it for you. It's all on you. Then you just have to put it over there. You can do whatever you want. So this is not a criticism of IaaS. This is the correct choice of Oracle workloads for basically for lift and shift migrations for regulatory environments, because you want full control of the entire applications and the databases and everything that is running on the server. You want that control, so you go for infrastructure as a service for everything. Usually, in the real time, what we do is we use this infrastructure as a service mostly for the applications. Now, type of application you have. And if you have a e-business, the application server resides on these compute nodes, not the database. But databases, we want to give the cloud provider little more control to the cloud provider and little less control for the engineers here, like taking backups, taking patching the databases, and going a little more further. Not even patching the databases, you go for the PaaS models of the databases. So there's a different topic altogether. We will discuss about it when it comes to the databases. So in real time, these IaaS models are mostly used for application servers, where the applications are very customized, and we want to offer the control on the operating system. So that's the IaaS model. As we move up the abstraction ladder, something interesting happens. You stop thinking about the infrastructure and you start thinking purely about the outcomes. Platform as a service, you focus on your application. The cloud manages everything underneath. The beginners, it's like the service apartments. Furniture is included, everything is included. You just bring your personal belongings. For mid-level engineers, you deploy a Docker image to OCI Kubernetes. Now, OCI Kubernetes is a PaaS service where it handles the Kubernetes as a managed service. So here, you are not going to patch the operating system. There's no kubelet to configure here. It's been already managed by Oracle OCI. The platform handles node provisioning, and then upgrades, and the load balancing as well. But, and this is the catch, you can't change the Kubernetes version mid-cycle. You're on the platform's schedule. Now, for architects, PaaS abstracts the runtime of the cost of portability. Let me put it like this. So every managed service you adopt is a potential lock-in point. Before using any PaaS service at scale, ask yourself, if I need to leave this vendor tomorrow, what would it cost? No, SaaS, software as a service. No, this is like just log in and work. For the beginners, it's like a restaurant, and for the architects, it introduces the third-party risk into your availability SLAs, because here you are dependent on your third party. When Oracle Fusion has a downtime, the Oracle from the Oracle OCI, your finance team cannot post journals. So we are here dependent on the third party. So we are dependent here. So that's the setback over here. Apparent setback, of course. I mean, it depends on what type of applications you use. So, but from the responsibility perspective, there's a lot of responsibility you are getting rid of. And for the FaaS model, called as a serverless technology, although there is a server running behind, but for the user, it's purely serverless. You don't need to worry about the type of number of OCPUs, the number of the amount of memory or the storage. You just push some function. You have a job to be done, and then that job you just push it to these functions. It could be a Lambda function on AWS or OCI functions. You just put up some function over there, and then it runs the back end, and then just gives you the output. You're just worried about the output here. Further minimized responsibility on the customer. It goes most onto the cloud. Now comes the cloud deployment model. Most of the cloud architects are not the ones who are taking the decision about which type of deployment model they are going to choose, because this is very high level decisions that are made by the company. And the reason why you choose these deployment model is purely not technical. For example, like your company is a government entity and it has its own rules from you cannot have your data outside the country. It cannot reside in any other country. When you look at the public cloud regions of any cloud provider, let's say OCI, Azure, or GCP, they have some specific regions throughout the globe, but not in every country. If you go in Middle East, there are assume like there are 10 countries inside Middle East, but the around 5 to 6 countries hold the regions, which means the physical data centers are there. But the countries where there are no data centers, and if they have the ruling that the companies residing inside this country cannot reside in any other data center which is outside this country's region. So in such cases, this public cloud will not be an option. So this decision will be taken by sometimes by higher management of the company, and sometimes even it's beyond the company's board of directors. It's decided by the government itself. The data center, physical data centers, which the cloud providers already have throughout the globe, that will be listed inside each of their consoles, like which particular region you are going to choose. And the private cloud, if we take an example of OCI will be providing a console which will be exactly similar to the public cloud. You have all the options running over there, and it depends on what is available in that particular region. And then you can access all the servers which are present inside your data center through the OCI console, and leverage all the benefits from the OCI cloud. So that's something about the private cloud. And then comes the concept of hybrid cloud, where the companies may have an option of running their workloads partly on their data center, partly on the cloud. Sometimes nowadays, it's the most common thing is the DR is they choose the DR to be inside the data center, and the production databases inside the public cloud, and vice versa. Sometimes it will be the other way around. So that's what is the hybrid cloud. And multi-cloud, here the decision making comes in, like, or being an architect, you decided saying that our application is more suitable in Azure because of the ecosystem, and the AD, Azure Active Directory, which is now Entra ID, by the way, is very much embedded within the application, and we cannot come out of the Azure or Microsoft ecosystem. So that's one decision which application team makes, that they will opt for the Azure. And the database team makes the decisions for the performance reasons, or for the best-in-class high availability, that is the RAC, real application clusters, or the Exadata, the high-performance systems, the extremely high-performance systems of Oracle are the best choice. So here comes the multi-cloud environment, where you choose for the database as Oracle, and you choose Azure for the application servers. And then you have many other options that are available in different clouds. The variety over there, the AWS is coming with a different choice of options, and then GCP is having a different choice of options.